Hi, this is Jatin Bhosle from Embedos Engineering. Today I'll be showing you the EM IO gateway and data logger device. This EM device has got digital inputs, analog output, and digital outputs. It also has CAN bus and RS485 bus. It also has built-in Wi-Fi and GPRS technology for connecting to the internet. Now in this application, we have connected this analog input simulator to the analog input channel 1, and based on this we will be controlling the digital outputs from the device. Now, the device comes with its own web page that is used for viewing and configuring its settings, as well as some basic dashboard uh, operations. So we'll be opening this device's web page. Now this device is already connected to the Wi-Fi. So we'll open the web page by simply entering the in our web browser. Now this is how the web page is loading. This first page is the IO monitor, which is now loading all the analog input channel data. It also has indications for digital inputs and outputs, as well as analog output, which is currently disabled. Is loaded, you can see the gauges. Now we also have reports section, protocol configuration, device configuration. Let us first see the protocol configuration. Now the device comes with Modbus RTU, TCP and MQTT configurations. So here are the settings for Modbus RTU, and these settings can be directly changed by selecting from the drop down. Then we have Modbus TCP. So the current port, as you can see, is 11502, which can be changed by clicking on edit and then sending a new. Uh, and we also have MQTT available. So these are the currently configured details. So the device sends all of its IO data to the topic mentioned here. Now let us see the device configuration page. The device comes with Wi-Fi capabilities. So we can go and just click the scan Wi-Fi button, and the list of all available Wi-Fi networks would pop up. Yeah, so this is the list of all available Wi-Fi networks. Now this is currently connected to Embedos 2.4G network, and this is the IP address. Now the device also generates its own hotspot as shown here. Now this hotspot can be found on your laptop, and then you can connect to it and enter this IP to access the same web page. We also have analog input settings, wherein we have four analog input channels, and for each and every analog input we can set the input parameter name, its unit, and the number of decimal places that we want to use. So let's try changing one of them. So now I have changed the parameter name to analog input test. I'll enter the unit as centimeters and number of decimal places as 2. So this takes anywhere between 0 to 4 decimal places, and then I'll press on submit. We get an indication here that successfully data sent, and the same data is updated here, analog input test centimeter and 2. Here are the settings for calibrating all of these analog input channels. So we can simply select the channel and the calibration type. So we offer manual calibration, ADC calibration that calibrates the ADC with respect to our usage, and then we have 2 point and zero span calibration. So now the device is already calibrated for 4 to 20 milliamps. Here is an indicator for digital outputs. So in order to test the digital outputs, we have to switch the maintenance mode on. When the maintenance mode is completely switched on, we can turn on individual digital outputs in order to test the working. Yeah, and we'll switch off the maintenance mode once again. Now the maintenance mode is turned off. You can see all the digital outputs are turned off. Uh, We can also see SD card that the device currently has and its basic configurations. The device also comes with an RTC. So these are the current settings. So this is the current device time. We can also update the time to whatever duration we want to set it, as well as we can sync it with the computer. Now we have given this firmware update option in case there is a newer upgrade available for the device, as well as you can directly download the user manual by clicking on this download. Now this device also provides an option to set up customize events. So we'll just go to add events. Now this does not have any event setup. So in order to set up our first event, we'll click on add event and then select the analog input channel that acts as a trigger. So currently I've connected this analog input simulator on channel number 1. So I'll select analog input 1, and now there are two types of set points available. One is a simple set point. So there just one single value comes in, and then we can set whatever digital output should be turned on above the set point and whatever should be turned on below the set point. And there is another option, that is the window function, wherein we have two different set points, and then we can create a window out of it, or we can treat it as three different regions as well. So we'll just try custom setting the window function. So now our analog input 1 is set to work between 0 to 100, that is the calibrated data. So I'll set up its value as 30 and say 70. Now we also get option to select the color of gauge that we see on the page 1. So I'll just select uh, a little bluish color for the below the first set point, and then between the two set points I'll select something towards green, and then final I'll select something towards orange. Yeah, so these are the three colors that we've currently configured. And then this is the state of all the digital outputs at different regions. So let us say below the first output, I have to turn on first DO, then between the two set points, second DO and third DO. And a fourth one I'll randomly put up anywhere, and then I'll just click on submit. Now we can see that this analog input test, now this is the parameter name that we've given. So this event has been created. We can add multiple events. We have total 4 channels, and we can add uh, events for all 4 channels. Although we cannot repeat the usage of channel as well as the digital output. Since now this is used up, we cannot use it for another event. Now we'll go on home, and we can see this gauge color is already updated. Now since the range selected, now the current status of this is below the low set point, that is why the digital output 1 is turned on, you can see on the device. Now when I just go and increase this value, now when this value crosses the below set point region and it goes into the between two set points region, that is when the second and fourth digital output is turned on as we had configured. Now we'll go completely ahead into the third region, that is the orange region. Now when I go into the orange region, we can see that the third digital output is turned on. So in this way, all 4 digital inputs can be configured. And the same digital outputs can be seen on the digital output section as well. So when I turn this back low, second and fourth is turned on, and below this again first is turned on. So this is also seen on the web page. Although now, because these 4 digital outputs are used up by event, so we cannot turn them on manually, and the same option is given for all the unused digital outputs. So in this way, we can set up all these 4 analog inputs to control digital outputs, as well as all this data is available on MQTT and RS485, uh, Modbus RTU, as well as Modbus TCP using Wi-Fi. Now the device also provides option for storing all the IO data into its internal storage. So currently we've configured to store the analog input, and we can download that data by going to this report section, and by select now here we have to click to select the date range. So this is the date range, so we'll just select between 19 to 23 and then press on load button. So now this sends a request to the device, and the device responds with all the data, and then it sorts it into uh, multiple pages. So we have like 73 pages because that's a lot of data. We'll just try to change the number of entries in one page. We'll turn it to, let's say, 100. So now it again sends a request, and now 100 entries are loaded into one page, and then there are total 8 pages. We can browse through all of them one by one, and we can go on the last page. So this has less number of entries, and now we can also download this data, the entire range for the entire range of date that we've selected, in a CSV format, which is openable in Excel. And we just have to, now this is the default file name that is given, which is the date range. We can simply click on this, and then I'll type my file name and click on download. So this again gets all the data, and it converts it into a CSV file, and that CSV file gets downloaded into the computer. So it is now getting downloaded. We'll just open it and see quickly. So this is the Excel file. This is the CSV file that we've downloaded. So we have column for timestamp, and then analog input 1234. Now note that these column names are basically the parameter names that we've given, and in the bracket we have the parameter unit that was set on the device, and then we can download all this data and store it. Also note that this reports as well as the file downloading structure can be completely customized based on your requirements, and the same can be provided to you. Now let us see how this device works as a Modbus slave. So we'll first see Modbus RTU. So these are the configurations for Modbus RTU. Now since this device is a Modbus slave, we'll have to use another utility. Uh, Here we are using a utility called QMod Master, which is a Modbus master simulator. So we have connected, as you can see here, we have connected the Modbus RTU terminal with an RS485 to USB converter, and then from that the data is communicated with my computer. And this is the QMod master, wherein I'll first configure the data. So this is the serial port for my USB to RS485 converter. Then this is the baud rate, data bits, stop bits, parity, RTS, and then the total number of resistors that are provided with this device pre-configured are 28, which you can see in depth in the user manual. uh, Data format decimal, start address 1, and I'll press on connect and then press on poll data. So as you can see, it is getting data, so I'll put it on continuous poll. Now the first two places that we can see here are basically the calibrated analog input data, and this is the ADC reading that we are getting for channel 1. So when I just increase this, we can see there is an increase in the values in the first two registers, as well as the uh, ADC raw data register that I just shown you. Now similarly, we'll try to see how the device works as a Modbus TCP slave. So I'll go to Modbus TCP. Current port number is 11502. We'll again open QMod master, and from here I'll just turn this. Now we'll see how this behaves as a mod TCP slave. I'll just turn this off and then I'm sorry, go to Modbus TCP settings. So the IP address for this device currently is 192.168.0.27 and the TCP port number is 11502. Press OK and connect to it and then connect and then poll data. So this is the data that the device is currently sending. So this is how the device works as a Modbus TCP uh, slave. Now we'll just see how it works as an MQTT device. So this is the topic. I'll just copy it and then open MQTT box, which is another simulator for that acts as a simulation for receiving the MQTT data. So as we can see, currently here the interval for sending data is 10 seconds and the broker URL is this as specified. Now also note that this device also allows you to configure this table to also include other peripheral data like digital inputs or digital output or analog output or state change operations. Now this also has an option wherein you can customize this to log a certain data on occurrence of certain events, and all of this can be made completely customizable based on the application. So the analog and digital input data can result into generating some sort of digital or analog output or some message logging into this table, and all of that can again be downloaded as a CSV file from the exact same utility. Thank you so much.